Technion presentation system.
Initiating.
Hollow memory.
Activated.
Netcom links.
Activated.
Teleconferencing.
Activated.
Master interface.
Activated.
Virtual world.
Activated.
Virtual cam.
Activated.
Tri-screen video.
Activated.
Surround sound.
Activated. System ready.
Shalom, ladies and gentlemen, and welcome to the Technion Virtual Studio. My name is Professor Brian Silver. I'm from the Faculty of Chemistry, and I will accompany you on this very unique tour. On the lower floor, you were told about Technion's contributions to the State of Israel. But here, in the special virtual studio, we want to take you on a tour of Technion vision of the next century. Unfortunately, or perhaps fortunately, I will not be able to tell you the tour's program in advance because it will be determined by TC in real time. TC's full name is Technion Virtual Center, and he or she is a computer hooked up to about 280 different sites on campus.
286, Professor Silver.
Shalom, TC. Perhaps you could come a little closer so that we can all see you. As I mentioned, TC is hooked up to 286 predetermined visiting sites, and based on a special code, he checks where there are interesting activities and who is available and where, and brings him to us or takes us there. TC, show us an example. What are we seeing?
This is a simulated flight over the State of Israel, developed at the Technion by Professor Craig Gotzman and his colleagues in the Faculty of Computer Science. The software integrates satellite pictures and topographic data and produces a synthetic panoramic picture viewed from any given point.
If this is a synthetic picture, then what more can you offer us?
In the Faculty of Architecture and Town Planning, there is a seminar on Israel in the year 2020.
That sounds a bit heavy for starters. How about some student laboratory?
There is activity in the robotics lab. Shall we go there?
Okay.
The Computer-Aided Manufacturing Laboratory in the Faculty of Industrial Engineering and Management was established to enable students to acquire the know-how and experience essential for engineers and scientists in the next century. Some of the systems in the laboratory envisage the need of Israel's industry during the next decades.
Quite impressive. TC?
Yes, Professor Silver.
Where to now?
Any preferences?
Well, how about a research center?
We have activities at the Transportation Research Institute, at the Asher Institute of Space Research, at the National Building Research Center, at the Solid State Institute, and at the Water Research Center, where Professor Shamir is ready to receive us.
Okay.
But he's at the Eshkol Water Reservoir in the Galilee.
Never mind, take us there. Shalom, Uri.
Professor Shamir is head of Technion's Water Research Institute.
Hello and welcome. We have invited you here to show you the work that is being done at the Water Research Institute at the Technion and its connection to Israel's water sector. There is probably no better place to demonstrate this than here at the heart of Israel's national water carrier. Some people have said that water may be the source for wars in the future. However, water may also be a bridge for peace in this region that is scarce in water resources. At the Water Research Institute, 50 staff members from 8 different departments at the Technion collaborate to provide the basis of science, technology, engineering, and management of water resources. We are collaborating with our colleagues from the other universities and research institutions in the country, and now also with our colleagues, Palestinians, Jordanians, and in the future, hopefully with others in this region, to provide the basis for better water management in the future.
Thank you, Uri.
We have an arrangement for a quick look at the Wolfson Microelectronics Research Center. We have a good signal now, so let's go there.
We are now in the clean rooms of the Microelectronics Research Center of the Faculty of Electrical Engineering. This center is the basis for advanced technologies for the microelectronic industries in Israel. A substantial investment in state-of-the-art equipment supports pure and applied research in different areas, including semiconductor crystal growth, detectors for infrared and X-rays, integrated microelectronics, quantum structures, and microelectromechanical systems.
Professor Silver, until our meeting with the President, let's show our visitors Technion's connection to Israel's industry.
Israel is in the forefront of scientific and technological research and development. To attain economic independence, this excellence must be translated into science-based export industries. A broader vision is needed, educating managers for high-tech industries. The Technion must take a leading position in all crucial fields of technology. The consortia set up by the Nieman Institute for Advanced Studies in Science and Technology encourage cooperation between industry and academia to develop generic technologies as the basis for future product lines, like wideband communication, digital communication, and multimedia.
Excuse me, we have a signal that Technion's president is ready to receive us.
Please go ahead.
Onwards to the President.
Hi, Brian. You wanted me to tell something about our vision of the future. Our vision of the future is an economically independent Israel, strong and advanced in technology and in certain fields dominant in the world market. We, the Technion, are the tool and the engine that can drive Israel toward economic independence. Because our mission will be, and it has been also in the past, to prepare the human resources, the engineers, the scientists, and the technologies that are crucial for Israel. Everything you see in Israel, be it in the defense infrastructure or civilian industry, one way or another can be traced back to the Technion. And the same is going to happen in the future, except now it's a little bit more difficult and complicated, because what happened since the 70s is that science and technology fused together into an indistinguishable entity. And therefore now, in order to get into new technologies, we have to create multidisciplinary centers of research in which scientists and engineers work together around a well-defined subject, a new technology. We have created a dozen different centers of excellence like that.
And what would you suggest we visit, Professor Tadmor?
I would certainly recommend that you visit the Optoelectronics Center, which is our first multidisciplinary center of excellence.
That sounds good to me.
Optoelectronics is not available right now, but we can visit the Interface Science Center of Excellence.
Interface science.
Then give my regards to Danny Shechtman.
I'll do that, Professor Tadmor. Professor Shechtman amazed the scientific community some time ago when he discovered the quasi-crystal state. And that state includes a whole group of compounds which has given his name, Shechtmanites. Professor Shechtman.
Welcome. Can we take a break for a minute? Welcome to the Wolfson Center of Interface Science.
Could you explain?
Okay, let me give you an example. As we know, ceramic materials are brittle. They're strong, but brittle. But here in my hand, I have a seashell. This seashell is also made of a ceramic material, but it is tough. And it is tough because nature has solved the problems of toughness by having many interfaces in between layers which constitute this seashell. If we knew how to make such materials, then we would have a very useful material in our hand, which would be ceramic, yet strong and tough. Let me give you another example.
Okay, thank you, Dan.
You're most welcome.
I'm afraid we're running out of time. That'll have to do for this time.
Thank you for coming.
Professor Silver, I have a signal from Optoelectronics. Do you want me to connect?
By all means, the President recommended it.
The Interdisciplinary Optoelectronics Research Center was established in 1989. Today, the center is considered large even by international standards, with 17 outstanding researchers from various fields: electrical engineering, computers, chemistry, and physics, conducting research on the different aspects of fiber optic communication, from the production of devices to the identification of uses for futuristic systems.
TC, Where do we go from here?
How about a short visit to some unique laboratories?
Go ahead.
I have a signal that an experiment is underway at the Israel Institute of Marine Engineering. The electron microscope is at this moment scanning gold samples. There is activity in the Faculty of Food Engineering and Biotechnology. In the Faculty of Aerospace Engineering, a major experiment is underway. A new robot is being tried out in the robotics lab of the Faculty of Mechanical Engineering.
Wait. Hold your horses. We keep on jumping from place to place.
Sorry, I just wanted to show how many places...
Never mind. Is there any place you haven't been to? Show me something completely new.
There's a completely new department of molecular genetics in the Rappaport Medical School campus.
Sounds very interesting. Let's go.
It is not a program site yet. We have never gone there before.
TC, what's going on?
I'm searching for Professor Levy.
Wait a minute. Would you please steady the cameras around here?
I'm trying. I'm moving into the auditorium. Excuse me, Professor Levy.
I didn't indicate I'm going to be free today, TC.
This was a special request by Professor Silver.
Let's see how I can help. Molecular genetics. TC, can you screen the movie Genetics, the Future of Medicine without the soundtrack? Future of medicine is in genetic engineering. We will be able to correct genetic defects at the level of the single molecule. 2 years ago, we decided that we have to join this revolution, and we established a unit of molecular genetics, and we recruited 5 new faculty members.
Professor Giora Shaviv is ready to talk to us about some of Technion's breakthroughs. Is it okay?
Okay, just for a few minutes.
Shalom to one and all.
Welcome to our virtual studio.
I want to start the journey through the Technion by showing you some of the problems that scientists at the Technions are working on. One of the greatest problems in astrophysics were the gamma ray bursts. These are gigantic explosions that take place every day at different places in the universe. The source of these explosions was unknown for over 35 years. A group of scientists at the Technion, led by Professor Arnon Dar, Dr. Nir Shaviv, and Dr. Ari Laor, have apparently solved this problem. Professor Dar?
Hello.
Professor Dar is a renowned astrophysicist in the Faculty of Physics.
2 neutron stars in a binary system are orbiting each other and are emitting a gravitational wave. The emission of gravitational wave finally brings them together. When they merge together, they create an enormous explosion. The explosion actually consists of cosmic rays, and when these cosmic rays hit the atmosphere of a planet like Earth, they produce secondary particles called muons. These muons are very killing particles. They are penetrating everywhere. Our research indicates that the 5 big extinctions in the last 600 million years on planet Earth could have been caused by muons produced by cosmic ray bursts from neutron star mergers.
Space application is another area which we at the Technion are interested in. Now, however, I want to show you a project which Professor Arthur Grunwald, an expert in computer graphics application to flight control, is working on, and this is the problem of space travel.
What you see here is a graphical interactive tool for planning orbital maneuvers around the space station. It's meant for the year 2002, where the space station is accompanied by a number of other spacecraft. And it's the intention of this tool to aid the astronaut in performing these maneuvers with minimum fuel and maximum safety.
It is amazing how what happens in the outskirts of the universe affects our life here. We move now to another topic. Professor Lifshitz, please.
This is a tomato plant, as you all know it. But the other plants are tomato too. They were obtained by genetic engineering techniques. It has recently been recognized that in order to design plants with favorable agronomical traits, we have to obtain much better understanding of the complexity and versatility of the genetic programs that make plants. And that is what we are doing right now.
An entirely different area is environment quality. We destroy the environment by producing energy. Here I want to call Professor Dan Zaslavsky, who developed a new and promising technology, energy towers. Professor Zaslavsky?
Professor Zaslavsky is out, but let's have a look at his invention.
The idea is based on converting the properties of the desert, hot and dry, into its assets by generating electricity in energy towers. A single tower can supply the electricity of Greater Tel Aviv, and the byproduct will be desalinated water from the sea. We saw a few examples.
Professor Shaviv, allow me to wrap it up. Energy towers, genetic engineering in plants, biological molecular systems are merely some examples of hundreds of research projects conducted at the Technion. They illustrate how Technion plays a dominant role in keeping Israel in the forefront of scientific and technological progress, on par with the best in the world.
It is amazing how things run fast when we discuss science at the Technion. So I'm returning you now to the good care of Professor Brian Silver and TC, and in the meantime, bless you all.
See you later on, Giora. It was indeed a pleasure to accompany you on this virtual tour, during which we were able to touch only the tip of the iceberg. And believe me, that what you have not seen is just as interesting as what you did see.
Professor Silver, we have still not seen the Israel 2020 project.
Well, let me tell you something. Everything we have seen belongs to the year 2020 and far beyond.